looking at the differential equations, and we are going to solve these equations with Professor Kamukama. And now, the meaning of differential equation. A differential equation is an expression that involves derivatives of some unknown function, and if the unknown function is a function of a single independent variable, then the differential equation is called an ordinary differential equation. And we have some examples of ordinary differential equations. Ordinary differential equations. Some of the examples we have, number one, we have derivative of y plus xy equaling 3. This is an ordinary differential equation because the unknown function y is having a single independent variable, which is x. This is the unknown function, and this is the independent variable because y is a dependent variable. Then we have number 2, which is second derivative of y plus 5 first derivative of y plus 6y equaling to cos x. This is the unknown function. Y is the unknown function, and then x is an independent variable. So because we have only one independent variable, which is x, and one dependent variable, which is y, these are ordinary differential equations. Then we have partial differential equations. These contain more than one independent variable, or they contain two or more independent variables, and those are called partial differential equations. We have examples of partial differential equations. And on number one, we have partial squared u partial t squared minus partial squared u partial x squared equaling to 0. This is a partial dE because the unknown function u is depending on t and also depending on x. So t and x, these are independent variables, while u is the unknown function or the dependent variable. So these are partial differential equations. We can have another example, which is partial u partial t equaling 3 partial u partial x. So this is another example of partial dE because the dependent variable u, which is the unknown function, is depending on t and also depending on x. So these are some of the examples of partial differential equations. Then in differential equations, we have some terms which we normally use, and one of them is the order. Now we have definition of terms. Number one, we have what we call the order of a differential equation. The order is the highest derivative which occurs in the equation. Is the highest derivative which occurs in the equation. So the order is the highest derivative which occurs in the equation, and for example, we have dy dx equaling to x plus 2. This is first order, or what we can call order 1, because y was differentiated for the first time. So our highest derivative is 1. So this one has order 1, or what we call first order, order 1. Then we can have another example. That one was A. Then B, we have d squared y dx squared plus 2 dy dx plus 3y equaling to 0. Now when you see this CDE, we see that y was differentiated for the second time. So, and we see that the order is the highest derivative which occurs in the equation. Now here we have the first derivative, here we have the second derivative, meaning the highest derivative is d squared y dx squared. And d squared y dx squared means that our function y was differentiated for the second time, meaning this is the second, this one is the second order. Then we can have another one. Now we can talk about partial. So we have partial squared z, partial x squared plus partial squared z, partial y squared equaling to x squared plus y. So in this equation, you see that z was differentiated for the second time because we have partial squared, meaning it was differentiated for the second time, and now this is the second order differential equation. We can have another example. We have second derivative of y, but this second derivative is squared. Then we have minus y, first derivative cubed, then plus 2y equaling to 5x. If you see this equation, these are just powers of the derivatives. 3 is the power of this derivative, and 2 is the power of this derivative. But the real derivative, here we have first derivative, here we have second derivative. So we should, to determine the order of the derivative, you come and see the highest derivative, which is this one. It was differentiated for the second time, and now we can say this is second order differential equation. These powers, these ones, we call them degrees, they are not orders. So the order, it is the highest derivative, but these ones outside, they are just degrees. And we also have another definition. We have what we call a degree, and we see that a degree is the is the power of the highest derivative appearing in the equation. It is the power of the highest derivative. It is not the highest power, but the power of the highest derivative. So you have to be keen about that. So, for example, we have examples here, and part A, we have 3 first derivative of y according to x plus 2. This differential equation has order 1 because y was differentiated for the first time, and so it is order 1 or first order. Then now the highest power, we here in the degree we don't talk about the highest power, but we talk about power of the highest derivative. And our highest derivative, of course, we have this first derivative, and its power, it is power 1. It is already power 1, so we say order 1 degree 1. Then we can have another example, which is the y first derivative of y squared minus 3y cubed equaling to 5. Now, this equation, y was differentiated for the first time. We don't have the second derivative, we don't have any other derivative. So our highest derivative, the highest derivative is the first derivative here, and its power is 2. Its power is 2. So we say this one is order 1. It is order 1 because it is the highest derivative. Then our degree, now you look for the power of the highest derivative, which is 2. This is power 2. So we say degree 2. We have another example. For example, this one, y third derivative of y plus 2 second derivative of y squared equaling to cos 2x. This differential equation, we see that y was differentiated for the third time. Here y was differentiated for the second time, but the power of the highest derivative here is 1, but the power of the second derivative, but this second derivative is not the highest derivative. So we are not going to take this power because our highest derivative is this third derivative. So, and the power of this third derivative, it is 1. But the order, we have order 3. We have order 3 because this y was differentiated for the third time, and the power of the highest derivative, it is 1. So our degree, we have degree 1. We also have another example, which is our last example on this. We have second derivative of y squared plus first derivative, and this is cubed equaling to 5x. Now this is the first derivative, this is the second derivative, but the second derivative is powered 2, and the first derivative is powered 3. Now order, our order here, we look for the highest derivative, and our highest derivative, we have the second derivative, so we have order 2. Then the degree, you look for the power of the highest derivative, and power of the highest derivative, our highest derivative was this second derivative, and the power is 2, so we have degree 2. So all in all, you will not choose the power 3 because you have seen it is the highest power. In a degree, we don't choose the highest power, but we choose the power of the highest derivative. So you first know what is order, you look for the highest order, and our highest order is the you look for the order is the highest derivative, and then if we are looking for the degree, make sure you first know the order, then you look for the power of the order or power of the highest derivative. Thank you. This is Professor Kamukama Darius.